Have you ever played a seesaw before? Well, Chatelier is all about balancing a seesaw. According to this principle, when a chemical system is disturbed, it reattains equilibrium by undergoing a net reaction that reduces the effect of the disturbance. Net reaction is the shifting in the equilibrium position, and total up, there are 5 disturbances or factors affecting equilibrium system: concentration, pressure and volume, addition of inert gas at constant volume or constant pressure, temperature and catalyst. Initially, the system is at equilibrium at which Q equals to K. When a disturbance is given, by increasing the concentration of Cl2, Q now is not equals to K. In order to reach the equilibrium again, the concentration of PCl5 need to be increased and the concentration of PCl3 and Cl2 need to be decreased. Thus, the equilibrium position will shift to the right. As a result, concentration of PCl5 increase, concentration of PCl3 decrease, and all the added Cl2 completely consumed during a reaction until Q is equals to K. Initially, the system is at equilibrium at which Q equals to K, and just after the disturbance is given, with increasing the concentration of ammonia, Q are now not equals to K. In order to achieve back the equilibrium, the concentration of nitrogen and hydrogen need to be increased and the concentration for ammonia need to be decreased. Thus, the equilibrium position will shift to the left, and this makes the concentrations of nitrogen and hydrogen to be increased and makes the ammonia consumed during a reaction until a new equilibrium is achieved. Initially, the system is at equilibrium at which Q equals to K. Just after, the disturbance is given, by decreasing the concentration of PCl3, Q now are not equals to K. In order to reach the equilibrium, the concentrations of PCl3 and Cl2 need to be increased and the concentration of PCl5 need to be decreased. As a result, the equilibrium position will shift to the left. Thus, it will adding all the removal PCl3 and at the same time Cl2 tend to be increased and the concentration of PCl5 tend to be decreased until a new equilibrium is achieved. Substitute all the original equilibrium concentration into the Kc expression, and once after the concentration of Cl2 is added, a new equilibrium is achieved, and substitute the data into the Kc expression, and we will find that both the Kc value are same. We can make a conclusion that Kc does not change with a change in concentration. Initially, all of these species are in equilibrium. Just after the ammonia was added to the system, the equilibrium tends to shift to the left to offset the stress. As a result, concentrations of nitrogen and hydrogen tend to be increased. Meanwhile, all the added ammonia will be consumed during a reaction until a new equilibrium is achieved. According to Boyle's law, pressure is inversely proportional to the volume. Thus, as increase in volume, it will cause a decrease in pressure or vice versa. According to Chatelier, the changes in pressure and volume can only be affected for a system in a gaseous phase and can only be observed when there is a changes in delta N. By increasing the pressure of the system, the volume will be affected by decreasing the number. Thus, system will respond to decrease the pressure and increase the volume. The equilibrium will shift to a lesser mole until Q equals to K. By disturbing the system with decreasing its pressure, the volume will be increased. Therefore, the system will respond to increase the pressure and decrease the volume. The equilibrium of the system will shift to a more moles in order to reach again a new equilibrium until Q equals to K.